I will now walk you through how to perform mesh analysis on simple circuits. But before I get started, I need to get a couple of things out of the way first. So first, mesh analysis can only be applied to what we call planar circuits. So opposed to other circuit analysis method, there is a little bit of restrictions because it only applies to planar circuits. So what's a planar circuit? Well, simply a planar circuit is one that can be drawn without crossing branches. Pretty much, let me explain it with this example in here. So in this example, you'll see that certain branches, like for example, this resistor in here is actually crossing this one, another one in here. And this branch is here and it's crossing this one in here. So as it turns out that if a circuit can be redrawn in such a way that these crossing do not happen, we call it a planar circuit. And you can pause the video a little bit and you will see that these two circuits are pretty much equivalent. These are the same exact two circuits. It is just that the 6 ohms in here and the 5 ohms were just basically pushed outside, and I was able basically to draw it on a plane, on a paper. So think about it this way, like if you can draw it on a paper without having any branches crossing, then you have what we call a planar circuit. So here's another example here. So at a first glance, you take a look at this circuit and you'll see, well, R8 and R7 are crossing, so this is not a planar circuit. But you will quickly realize that you can redraw R8 outside, basically. You can just do that. And this is what you see in here. So this one here is the R8, and these two are also equivalent. So this is another example of what we call a planar circuit. So the rule of thumb is the following. If you can basically construct the circuit on a paper and draw it on a paper without crossing wires, without crossing anything, that's a planar circuit. However, it's not always possible to get circuits that are planar. So for example, in here, there's a couple of examples of circuits that are not planar. So in here, you will see a 3D construction of a circuit, and you can pause the video, you can play around and redraw it as much as you can. You won't be able to draw it on one piece of paper without actually having wires crossing. The same goes with this one in here. You can probably push the R8 out, the R10 out, but then you will have this R11 or R7 are probably just will cross. So there's no way to draw these without actually keeping them crossed. Alright, so mesh analysis only applies to planar circuits. So if you get a non-planar circuit, you will not be able to use mesh analysis. Alright, so now with this out of the way, let's take a look at this particular example. So this example in here is a simple circuit that contains a few elements, a few sources, and a few resistors, and we will apply mesh analysis to get that. So what's a mesh? I've been saying mesh analysis, mesh analysis, mesh analysis. Certain people call it loop analysis because pretty much it applies to loops. So we already defined what a loop is. A loop is basically it's a path that starts for the one point and actually gets back to that point without actually crossing any of the other elements twice. So as long as you don't do this like that and you come back in here, that's a loop. So as it turns out, a mesh is a special loop that does not contain any other loop. So this one here is what we call a loop, okay? But that's not a mesh. And the reason why is because we have another loop inside it in here. For example, this is a loop and this is another loop. Okay, so a mesh is just a special loop. It's just a special loop that doesn't have any other loops in it. That's the basic definition of what a mesh is. So in this circuit, you can quickly realize that this here is what we call a mesh, because there's no other loops inside it in here. There's no way you can define another loop in it. And here is another mesh in here, okay? So now we identified the two meshes in the circuit. So the reason why we call these as mesh analysis is because we usually identify these meshes and then we say, okay, each one of these meshes will have what we call a mesh current. So in here, I'm going to assume that the mesh current flowing through the first one is this one, and flowing through the other one is this particular mesh. So we have two mesh currents in here, and we can call them, for example, I1 and I2 if you wanted to. You can call them IA, IB, whatever you want. So the way we perform these mesh analysis is, okay, let's identify the meshes first. Pretty much, you can think about them, sometimes people refer to them as windows because they look like windows. Okay, like this is a window, so forth, and so forth. So these are the meshes in here. So in this circuit, I identified two meshes. So as it turns out that I will be able to write two mesh equations, and by writing these two mesh equations, I'll be able to solve the whole circuit, and I'll be able to figure out what the value of I1 and value of I2. And if I know the value of I1 and I2, I'll be able to figure out the branch currents. For example, if I'm interested in here, they ask me to figure out what I0 is, I will be able to do that. And of course, if I know what I0 is, I know the 10 ohms, so I'll figure out what V0 is. I will be able to figure out what the branch current going through the 6 ohms, or the 15 ohms, and so forth. So how do we write these mesh equations? So I identified two meshes. I need to write two mesh equations. So let me just do that in here. So we're going to do that. I'm going to call it mesh 1. Okay. So mesh current, what you do is you apply KVL on that mesh. So I will apply KVL in this particular mesh in here. And as it turns out to be that you do not have to specify the pluses and minuses and pluses and minuses and pluses and minuses, or well, this one is already specified because it's a voltage source, and this one is specified because we need it, but you do not need to do that. So what you do is you assume that passive sign convention is okay and applies, and that the current that is going in here is actually going to the positive all the time. So this is going to the positive, this is going to the positive. Well, from the perspective of the mesh you're writing the mesh equation for. So I will focus first of all on this particular mesh in here, okay? And I'll write this equation and I'll show you how to do that. So first, what we have is this mesh current in here. It's actually hitting the negative first because I'm writing KVL. So I'm going to say negative 90 volts. Remember, we're adding voltages now. And in here, what we do is we say like, okay, this one here, I need the voltage across that 6 ohms. Of course, I could have just simply said, well, this is plus minus V6 ohms and whatnot. But I won't do this because mesh analysis is an analysis technique, so I just want to end up with like some sort of an equation that makes things easier. Anyway, so we continue. So what I will do is I will tell you like, well, this 6 ohms in here, the only mesh current that affects it is I1. So I can simply say that it's plus 6 I1. This comes from Ohm's law, by the way. The IR, basically. This is I and this is the R. All right, so we continue. So this resistor in here, the 10 ohm, is a little bit different than the 6 ohms. And the reason why is because this 10 ohm has two mesh currents affecting it. We have I1 going that way, and we have I2 going that way. And since they are going in two different directions, they're actually opposite to each other. From the perspective of the mesh we're writing that equation for, I will assume that it is plus 10. Because it is from the perspective of the mesh I am actually writing the equation for, that will be I1. And since I assume that the second mesh current is flowing that way, so it is because it's opposite to I1, I will just say negative I2. Again, this is the same as saying this is I and this is R. This comes from Ohm's law. Okay. If that for some reason or another, and I don't want to confuse you that much, but if for some reason or another I assume that I2 is actually going in the opposite direction, which is possible, some people do that, you would have seen instead of I1 minus I2, that would have been I1 plus I2 because they will be both in the same direction. Okay, but anyway, for now, I usually assume that the current is flowing in the clockwise direction or anti-clockwise, and I assume all of them are the same. I just find it simpler, but you don't have to. You can actually assume that it's that way or this way. It's up to you. All right, so we continue. I believe we have that 4 ohms in here. Okay, so for that 4 ohms, again, I1 is the only mesh current that affects it. So we can say just simply 4 I1, and that's basically equals 0, and that's the first mesh equation. Okay, so we have the first mesh equation. Let's figure out the second mesh equation. So I'll focus on this mesh in here, and I'm going to say, okay, this is mesh 2. Okay, I'm going to do it in a different color. All right, again, we'll go through the elements one by one. So I'm going to go in here, and I'm going to say this is plus 40, okay, volts. And then in here, remember, we're writing KVL equations, okay? So we're adding voltages in here. So since this 5, the I2 is the only one that affects it, so I can just simply say plus 5 I2. And now we go back to this 10 ohms. We have just recognized a few minutes ago that I1 affects it on I2. But this time, because we're looking at it from the perspective of the second mesh, so I will say plus 10, and now I'm going to say I2 minus I1, okay? So I assume that the I2 is the positive, so I'm assuming that it's I2 is the positive in here. And again, I do not have to write positive and negative. I'm just basically from the perspective of the mesh I'm writing the equation for, this is I2 minus I1. Again, I1 is moving in the opposite direction of I2, that's why it's negative. If they were the same, for example, I1 was defined in the opposite direction, that would have been positive. Okay. We continue. I believe that then we have 15 I2 because the 15 ohms in here, the only thing that affects it is the I2. And we can say equals 0. And now I have two equations. and two unknowns. And these two unknowns are pretty much I1 and I2. And if you solve these two equations, you can clean up these equations in here and figure out the I1 and I2. And you'll end up the I1 is just 4.6 amps and I2 is 0.2 amps. Okay, now that we know these two mesh currents, we can figure out anything we want about this circuit. So the question in here is, let's figure out what I naught is. Well, okay, well, take a look in here. So I naught is in the same direction as I1, opposite to I2. So simply, I can just define it as, okay, I naught is just simply I1 because it's in the same direction minus I2. And we substitute the values, it's 4.6 minus 0.2, and that's simply 4.4 amps. Okay. Of course, what about V naught? Well, V naught is just multiplied by 10 because IR, okay, and that will be 44 volts. Okay. And again, what's the current going through this 40 ohms, for example? If you wanted to, and you're interested in the current, you can just specify, well, I'm going to assume that the current going through it that way. Okay, so that will be, for example, I40 volts, I'll call it. Okay, so what would be the I40 volts? Well, simply the I40 volt is to the negative of the I2 because they're in the opposite direction. So I2 is here, I40 volts is going that way. So I can just simply say, well, this is negative 0.2 amps. That's what I can say. Of course, if I assume that the I40 volts is that way, it will be exactly the same as I2 and so forth. I assumed it in the opposite direction on purpose just to show you that you will need to put that negative in here.